In December 1941, the Imperial Japanese Navy unveiled something terrifying. This was the most fearsome warship ever built. A steel behemoth weighing more than 70,000 tons, developed under a strict cloud of secrecy and sporting the biggest guns ever to go to sea. Yamato, a battleship whose name has entered legend. When first built, her scale and firepower sent a shiver through her adversaries. But just how did the Japanese Navy build such an incredible weapon of war? What were the engineering secrets that made this Leviathan of the ocean work? And how was she finally and spectacularly destroyed? Ladies and gentlemen, I'm your friend Mike Brady from Oceanliner Designs, and this is the engineering of the battleship Yamato. Under the golden glow of a setting sun, a fleet of ships speeds on for a desperate mission. 8 destroyers and a light cruiser are escorting the enormous battleship Yamato, the largest in the world, the largest ever built. Yamato is loaded, absolutely filled, with tons and tons of cordite explosive charges and shells for her monstrous guns. Packed into crew bunks and messes are around 3,000 men, a staggering amount, but every one of them is required to operate this uncontested giant of war. The mission is called Operation Ten Ichi Go, Operation Heaven 1. Yamato, the cruiser and her escorting destroyers have been tasked with intercepting the enormous American landing force at Okinawa, the Ryukyu island chain about 400 miles south of the Japanese mainland. If the island falls, then Yamato's birthplace, the nation made of towns and cities that her 3,000 men call home, will be bombed mercilessly day and night on a scale not yet seen. That, and Okinawa would prove to be the perfect jumping-off point for a widespread invasion of Japan itself. The idea is to beach Yamato at the landing point, where she can throw up a merciless hail of heavy gunfire while, from above, Japanese army aircraft will conduct wide-scale kamikaze attacks in a desperate attempt to destroy as many American ships as possible. The plan is met with a mix of scorn and horror by Yamato's senior officers and others, but their sense of duty drives them on. What is about to happen is one of the great slaughters of naval warfare in our modern times. But to tell the story of this incredible machine and explain how it even worked at all, we need to rewind the clock to a very different place and time. (1918), and the war that had first engulfed Europe and then the world is over. In America and Britain, there is jubilation, but across the globe, in Japan, there is quiet recognition, and life just carries on. The land of the rising sun had proved itself to be a serious player in global politics. It had helped Britain fight against the German Navy's powerful Pacific squadrons, but the role it had played as an ally to the Western powers was secretly self-serving, because Japan's aim was expansion. Spreading its influence across the Pacific, Japan sought to turn neighbouring China into little more than a protectorate state. In 1918, the Japanese government knows it will need to use force to dominate the Pacific, and it will come to blows with the US Navy's Pacific forces to do it. It will need a whole new fleet of modern warships to stand a chance, and slowly a plan begins to form. 8 new battle cruisers and 8 new battleships will have to be built, and construction is underway before everything grinds to a halt. The 1922 Washington Naval Treaty seeks to limit the size of the world's naval fleets and the sizes of the battleships themselves. Japan, not wanting to lose face on the global stage, is one of the 5 signatories, but it's furious and reluctant. The treaty places a humiliating restriction on Japan's navy and stipulates that it cannot exceed more than 60% the strength of Britain or America's. This sows the seed of mutiny from within the Japanese navy that will eventually result in a complete withdrawal from the treaty. As the 1920s come to a close and the 30s begin, Japanese naval planners have conducted copious amounts of research and ideation, and as support builds for those that want to withdraw from the treaty, then the designs for a proposed series of super battleships begins to take shape. The Navy is aware that it cannot compete with the US and Britain in production. A long, drawn-out war would be hopeless for the Japanese and result in a devastating defeat. Instead, Japan's strategy for dominance in the Pacific would need to rely on a single, cataclysmic strike, what was then known as the Kentai Kessen doctrine of decisive fleet battle. America and Britain had more ships, but Japan would have the biggest and the best. It would need a class of super battleship that could engage multiple enemies at once, be fast enough not to catch, be well armoured enough not to be sunk, and be upgunned enough to knock out any Allied warship with a single hit. The stage was set for the design to begin, and in 1934, the curtain went up. Japanese nationalists and the government won out, and after a series of purges, the nation withdrew from the League of Nations and the Washington Naval Treaty. Designers were given a blank canvas. They got to their work with nearly a decade of research to go off of. The design was guided by simple principles: to be faster and heavier hitting than any American battleship it was likely to face. On paper, the Japanese Navy figured American battleships in the Pacific to be no faster than 25 knots, and for their gun calibers to be no greater than 40.6 centimeters or 16 inches. Engineers would need to design a platform capable of speeds of somewhere between 27 and 30 knots, and big enough to mount 46 centimeter, 18-inch guns. For the time, this gun caliber would be the largest ever mounted onto a ship, and in fact, it still is today. Designing something to achieve these numbers would be no easy task. The first design, A140, called for a monster of a ship some 294 metres and 960 feet long, some 69,500 tons, and, from turbines outputting 200,000 horsepower, a top speed of 31 knots. Now, this kind of size would have rivaled the world's largest passenger liners in the early 1930s. The naval planners realised they may have gone too far. The speed requirement was dropped down to a top of 27 knots, and the ship's size dropped with it. 24 revisions saw the ship's tonnage and length fluctuate, and from 1934 to 1937, the plan changed until a final set of figures was agreed on, construction was approved, and a keel was laid down at the Kure Naval Arsenal in Hiroshima. The keel alone was over 800 feet long. This new battleship's hull followed conventional design practices all ships need to follow. The keel, its backbone, was made of steel plate and ran for nearing the entire length of the ship, save for the turn of the prow and the stern post. The frames created the ship's ribs and gave it her form, and it was a unique form indeed. If we take a section of Yamato's hull at the waterline, we can get a picture of an almost teardrop-shaped hull with an extended, long bow that sweeps down to narrowly sharpen at the prow or the very front of the ship. The stern, by contrast, is fairly squat. This shape was extensively tested by designers and decided upon for one thing: speed. Yamato needed to outpace its American counterparts, so even before her engines were installed, the ship's hydrodynamic form needed to be perfectly optimized for a high pace. Moving 70,000 tons of steel over 25 knots is no mean feat. Here's how they did it. First, Yamato was designed to be extremely long. Now, this wasn't just to create as large a platform as possible to mount the biggest guns. Japanese naval architects knew that a longer hull form on a ship can produce greater speeds because of the way waveforms interact with the hull of a vessel. If the ship has enough power, it can maintain a speed at which the wavelength of interference washing along the hull is perfectly optimized to create as little resistance or drag as possible as it cuts through the water. Put simply by Professor Jerry Milgram, the longer the boat, the longer the wave it generates at high speeds, and longer waves move faster than shorter waves. Not only that, but when the wave created by the bow and the waves created by the stern meet, they can produce significant wash and drag, so keeping them further apart, by having a longer hull, can eke out even more speed from the ship before the two waves meet. But Yamato's designers had one more trick up their sleeve to minimize resistance from waves. They gave their warship a prominent bulbous bow, then the biggest in the world. Now, this trick had been discovered almost accidentally when rams had been installed on warships in the 1800s. It soon became clear that ships with the ram bows were quicker and more efficient than those without. The bulbous bow works by creating a wave ahead of the actual bow of the ship in such a way that at a vessel's desired operating speed, the wave forms interfere and cancel each other out, creating a minimal wash and therefore minimal drag. On ships of nearly all classes and sizes, this can save a monumental amount of fuel because the ship can simply move cleaner through the water. Yamato's long, thin, teardrop-shaped hull was designed for the other ways ships can maintain their speed, from slicing through heavy weather. The ship's hull is like a chisel, and its long, thin bow was perfectly suited not for riding over big waves, but for cutting into them and maintaining the vessel's speed while she did it. It meant that in rough weather, Yamato could maintain her pace. But here there was an issue. In having such a long and thin bow, like an ocean liner, there was simply less ship there to float or maintain the buoyancy. It might mean that her bow could drop into the waves and wash green water right over her forecastle deck and her guns, bleeding speed and endangering her crew and machinery. To counter this, Yamato's bow featured extreme shear. It flicked upward and then flared dramatically outward above the waterline, essentially providing simply as much buoyant structure as possible to lift the bow and keep Yamato's head above the waves. But the flare also served to make sure that Yamato's enormous anchors were well away from the bulbous bow below. In this way, Japanese designers had conceived a hull shape remarkably modern, even by today's standards, with more in common with record-setting ocean liners than traditional battleships. They tested and perfected the hull on more than 50 models at a tank in Tokyo. The result was that Yamato's smooth shape meant that her engines would need to operate at about 15,800 shaft horsepower less to get her to a 27-knot desired speed. To propel Yamato through the waves, her engineers needed to decide on a powerful but economic propulsion system. You could design a set of engines to be as powerful as possible, but brute force consumes enormous amounts of fuel, and the battleship's range would be severely limited. It was a delicate balancing act between power, speed, range, and efficiency. Early on, designers had looked at equipping the ship with only steam turbines. These monstrous machines use a system of fan blades to turn a rotor as steam is blasted over them at extremely high pressures. This kind of engine had driven ocean liners to extreme record-setting speed since 1907, but Yamato's designers knew that the boilers consumed vast quantities of fuel oil. A second kind of propulsion was considered, the diesel engine. In 1935, Japanese engineers had developed very powerful, double-acting diesel engines capable of outputting 10,000 horsepower. The plan was to equip the new battleship with a hybrid system, a pair of diesel units driving a propeller each, and a pair of steam turbines driving two more. It would give the warship a theoretical range of over 9,000 nautical miles at her cruising speed, but then they ran into a problem, and it was all to do with the warship's core reason for being. Yamato was no speed queen ocean liner. She was a battleship, and she had to slog it out with some of the fiercest floating artillery batteries in the world. American warships fielded 16-inch guns that could hit hard. If a shell penetrated Yamato's decks or hull, a single catastrophic explosion could send her to the bottom in seconds. Designers set about constructing what was essentially an enclosed bathtub of armour to protect the battleship's most vital spaces, both from above and below the waterline. Now, this was standard practice on virtually all battleships, but what was unprecedented was the sheer thickness of Yamato's armour. The armoured citadel encased spaces running from the aftermost gun turret to the forwardmost gun turrets about 600 feet away, extending 2 or 3 stories below the waterline for maximum protection. To prevent penetration from enemy shells, the idea was to minimise the amount of flat surfaces and angle the armour as much as possible. A shell passing through angled armour is, first of all, more likely to be deflected by the angle, but if it penetrates, it has to simply pass through more steel. Absolutely critical to the survival of the ship was the protection surrounding her 3 powder magazines, here, here, and here. One hit into one of these, where tons of cordite explosives were stored for her guns, would be the end. To do this, the armoured bathtub was provided with absurd steel thicknesses. At the side, 410mm or 16 inches of hardened steel. After a decade of research, engineers had managed to harden the top 140mm or 5.5 inches of the steel, providing an extremely durable and difficult to penetrate surface. The armoured box's top was only 200 to 230mm thick, about 9 inches, but this alone could protect the top of the citadel from hits fired out from over 30 kilometres away. In fact, to penetrate the armour, a 1,000-kilogram bomb would need to be dropped accurately from over 3 kilometres or nearly 10,000 feet directly above. For good measure, an additional layer of protection, a 9mm or 0.35 of an inch thick layer of steel, was added, spaced below the main top armour to protect the inside of the citadel from splinter damage, just in case a hit got through. The forward and rear ends of Yamato's armoured citadel were protected with sloping faces up to 340mm or 13.3 inches thick. A transverse cross-section of the ship reveals the dramatic angle applied to the side armour, as well as its extreme thickness at and above the waterline. Outside of this armoured box were installed torpedo protection bulges, which were essentially vacant spaces which could detonate a torpedo before it could hit the armour behind it. These were divided into watertight sections and provided even more buoyancy for the massive hull. The Japanese Navy had learned from gunnery trials that hits falling short of their target were very effective at travelling underwater and hitting the hull below. Here, Yamato's enormous torpedo bulges could serve to trigger a shell's fuse and then detonate it long before it reached the armoured plating behind. Unlike conventional designs from the time, Yamato's armour wasn't simply added for good measure, it was actually integral to the structure, a concept pioneered among Japanese naval engineers with their heavy cruiser Furitaka. Combined with a prevalence of electric welding over riveted construction, Yamato was built extremely strong, but also, counterintuitively, quite light for a vessel of her size. All in all, Yamato's extensive armour weighed around 22,900 tons by itself, accounting for about 30% of the ship's entire displacement. The armour alone weighed as much as nearly 2 whole American Liberty ships. It made her the most well-protected battleship in the world, but it presented an issue for her builders. The armoured box surrounding her engine room would make it impossible for the huge diesel engines, their solid blocks, to be replaced. Turbines, meanwhile, would fairly easily be disassembled into individual components. Yamato would need to be powered by the turbines alone. It was a blow because it reduced her operational range from about 9,000 nautical miles to just 7,200. But still, with a shaft horsepower total of over 150,000, her 4 turbine engines could each drive a screw that would push Yamato forward at enormous speed. Down into her hull were lowered 12 huge camp-on boilers in rows, separated into different compartments in case one should be hit, and each capable of outputting steam under huge pressure at around 325 degrees Celsius or 617 Fahrenheit. At her sea trials in November 1941 between the islands of Kyushu and Shikoku, the enormous battleship roared ahead at over 27 knots. She was capable of these sprints for short distances only. With all 12 boilers firing, Yamato would need to burn some 63,000 kilograms or 138,000 pounds of fuel oil per hour. Her standard operating speed was instead just 18 knots. Still an impressive figure, and one which made full use of her sleek hull form, giving her a coveted efficiency ratio that meant that her hull was working to reduce the power load on her engines, therefore burning less fuel. Within the confines of that efficient hull, consideration was given to battle damage and its effect on Yamato's fighting ability. The huge voids within the ship were heavily compartmentalised into around 1,147 watertight compartments, with all but 82 located below the heavily armoured middle deck. Here is where the damage to Yamato could prove fatal, so isolating and preventing the spread of flooding or fire was paramount. Thanks to the layout of these compartments, were Yamato's bow or stern sections outside of the armoured box to flood from bomb or torpedo hits, the battleship would have plenty of reserve buoyancy to spare. That and her forward freeboard, the amount of ship actually above the waterline, could drop to as little as 4.5 metres, nearly 15 feet, from its usual 10 metres, or 33 feet, and the ship could still remain afloat. Not only that, but thought was also given to the ship's stability. Sustained damage to one side could cause her to roll, and Yamato would be able to remain safely afloat and stable, even if she rolled by as much as 20 degrees to one side. Clever design choices were made for her funnel uptakes as well. The well-placed bomb could soar straight down a ship's funnel top and detonate within the boiler room below. To counter this, the funnel uptakes, which carry the boiler's gases and smoke up through the hull and out through the funnels above, passed first through an armoured grating 380mm or 15 inches thick, which was perforated with holes to actually allow the smoke to pass through it. Not only that, but the funnel itself was heavily raked backwards at a very awkward angle, plated with armour itself about 50mm or 2 inches thick, so that a lucky bomb hit would simply detonate inside the funnel itself. If it just so happened to bounce and rattle its way down the funnel instead, it would then be met with the 15 inches of hardened molybdenum alloy armour plate. Finally, with her hull compartmentalised and her machinery spaces protected by the armoured citadel, Yamato's main and auxiliary rudder machinery rooms were both enclosed in their own miniature armoured boxes below the waterline, both protected with steel between 200 and 360mm, 7.8 to 13.8 inches thick. Even under sustained heavy shelling, Yamato should still be able to steer herself out of danger. This was a vast, floating, armoured fortress, the likes of which have never been seen again. This floating fortress needed not only to take hits and survive, she needed to give them back, and her designers had big plans for her armament. The decisive battle doctrine dictated that Yamato's guns needed to outperform anything else at sea, and planners took that idea very seriously. So secret was the gun chosen that even recording its true size and character was strictly forbidden. They were referred to simply as the 41cm or 16-inch special type. But the horrifying truth was that this 41cm 16-inch gun was actually a monstrous 46cm 18.1-inch unit, nearly 70 feet or 21 meters long. These were arranged in threes within outrageously big turrets capable of rotating through their full field of fire, either forward or to either side of the ship. The statistics of the guns themselves are mind-blowing. The Type 94 460mm gun made for Yamato used 6 bags of cordite explosive charge, each 55 kilograms or 121 pounds. To fire one shell, 330 kilograms or 727 pounds of charge would be needed. The main shells alone weighed 1,460 kilograms. That's 3,218 pounds, about as much as a small family sedan. Each turret could fire 3 of these shells every 27 seconds, meaning Yamato could send over 26,000 kilograms, nearly 60,000 pounds of metal, hurtling downrange every minute. Those 6 bags of cordite could send the shells out to an extreme maximum range of over 40 kilometers, about 25 miles. The turrets these monstrous guns were housed in were themselves marvels of engineering. Each completed assembly weighed over 2,700 tons, or about as much as one of the battleship's escorting destroyers, and she carried 3 of them. Fitted to cavernous circular voids on the ship's weather deck, the turrets were geared to twin 500 horsepower hydraulic engines, which could turn these massive units at about 2 degrees per second. Their weight came largely from their armour. The turrets had to be heavily protected because they reared up high above the armoured citadel below, and they'd be a natural target for sustained enemy gunfire. Their roofs were 270mm or 10.6 inches thick, and their sides a minimum of 250mm thick. But the turret faces carried the heaviest armour found anywhere on the ship, a full 650mm, nearly 26 inches of solid steel. The gun's barbette ran stories down like a tower into the armoured citadel and housed the cordite charges and shells along with the hundreds of men required to operate the guns themselves. The barbettes alone needed up to 560mm or 22 inches of armour to protect them from direct hits. Yamato's shells came in 3 types. The first was the Type 91 armour-piercing projectile, 1,460 kilograms. It featured a special wind and water-resistant shaped hood cap that could protect the shell in its flight, but if it fell short of target once it entered the water, the shell's shape was ideal for plunging ahead into the soft underbelly of a target. The shells were made of steel and featured an explosive trinitroanisole filler that once the shell had penetrated the armour of the target, the fuse would activate, the 74.6 pounds or 34 kilograms explosive would detonate inside. The shells moved through the air at about 2,560 feet per second, or 780 meters per second when they left the gun barrel, faster than a bullet fired from an AK-47 rifle. With that much steel flying that quickly, it's no wonder that Yamato's guns boasted some devastating capabilities. A single hit could punch its way through nearly a half meter of armour, that's 19.4 inches of solid metal, out to 20 kilometers, or over 12 miles away. Yamato was also equipped with a high explosive shell, which was surprisingly light for a caliber of that size. 60 kilograms or 136 pounds of trinitroanisole were packed into the shell that was designed only for soft targets. By contrast, British warships back in the First World War had fielded significantly bigger explosive charges in their much smaller 13.5-inch guns. It's clear that Yamato's ultimate purpose was to slog it out with the battleships of the American Pacific Fleet, and armour-piercing capability came first. The third kind of shell Yamato could lob was a unique feature of Japanese battleships, the Type 3 Sanshiki anti-aircraft shell. It worked as a kind of monstrous shotgun, fired from the main guns where the fuse would detonate at the desired height. The detonation unleashed about 996 incendiary tubes, which threw fragments forward, burning at some 3,000 degrees Celsius, over 5,000 degrees Fahrenheit, for 5 seconds. It produced a cone of flame about 5 feet long that attacking aircraft would have to fly through. So seriously did the Japanese Navy take the threat of America's air power that nearly half of all of Yamato's ammunition was comprised of the anti-aircraft type. Yamato's sheer weight of shot was impressive, but getting all that metal on target tens of kilometers away was no easy task. The 46cm guns were fairly accurate, giving spreads of about 400 or 500 meters at maximum range. Relatively small dispersal patterns for that extreme distance, but they could have been more accurate. Yamato's designers had been flirting with the idea of 18-inch 50 caliber guns that would have made them around 5 feet or 1.5 meters longer than the ones fitted, but the huge additional weight and cost was deemed just too much, and they settled on 45 caliber. The guns could fire of their own accord because they were fitted with rangefinders and periscopes in the turret, which meant they could engage the enemy independently without direction from the fire control or bridge. But the secret to Yamato's accuracy was her advanced fire control setup, the ship's eyes and ears, which guided the gunfire with devastating effect. Japan's battleship fire control systems were vastly different to their American counterparts. The Americans relied heavily on radar-guided gunfire, but Japanese radar technology had lagged behind. Instead, Japan's gunfire control systems relied on superior optics and a complicated system of computers to manually track targets. It all began way up here, towering over the bridge, hundreds of feet in the air. This was the main forward 15-meter rangefinder, one of 4, the other 3 being found down in the gun turrets themselves. This piece of machinery used a set of reflectors, one movable and one fixed, to triangulate a range to target using trigonometry. This data was sent to a computer, the Type 98 Shageki Barn, operated by 7 men located in the Fire Control Center, which could be fed with the target range, as well as the subsequent corrections to gunnery. A separate but linked system, the Type 98 Soku Tekiban computer, focused solely on target speed and heading. All of this information was passed on to the Type 98 Hoi Barn gun directors, the main fire control units which calculated all the firing solutions. This was the crucial information the gun crews needed to train their huge turrets, and the Hoi Barn were mounted inside lightly armoured pillboxes, one atop the 15-metre rangefinder, and the other atop the secondary fire control 10-metre rangefinder further aft, behind the funnel. The data was fed electromechanically to the gun turrets, where an operator essentially ensured the gun's elevation and training matched the order from the fire control system, with inputs in a method known as follow the pointer. There was one final system in place. The Type 98 Soku Tekiban introduced an interrupter that essentially staggered the firing of the guns so that no two went off at exactly the same moment, and their shells wouldn't interfere with one another in their flight. So huge was the blast from the main 46cm guns that the bow forward of the first turret was almost devoid of structures because otherwise the muzzle pressure would simply sweep the decks clean. Yamato did make use of radar. As new, she featured Japan's latest type, the Type 21 Go Dentan Kai, which could detect air targets out to about 120 kilometers or 74.5 miles, but large sea targets only out to about 30 kilometers or 19 miles. The radar's arrays were installed atop the mast. The set was upgraded during the course of her career, but radar-directed gunfire was only a primitive concept in the Japanese Navy at the time. Yamato could pick her targets up from miles away, but it would be up to the optics-focused fire control system to guide the gunfire. Staggered between the 3 enormous main gun turrets was a dizzying array of secondary and anti-aircraft guns designed to engage smaller and lighter armoured targets. The undisputed kings of Yamato's secondary battery were actually the main guns from the light cruiser Mogami. These were big 15.5cm, 6.1 inch guns which could lob their shells out to over 25 kilometers or 15.5 miles. Essentially, Yamato was so big, she carried the main guns of what would have normally been one of her escorting cruisers. Each of these turrets weighed nearly 200 tons by themselves, and the battleship carried 4 of them. Backing them up were 12.7cm or 5-inch guns mounted in twin gun turrets. These Type 89 5-inch guns had a blistering rate of fire, somewhere between 8 to 14 rounds per minute or so. They could be trained and guided by high-angle direction to engage enemy aircraft. Finally, scattered around in open-top mounts were the lighter anti-air guns, 25mm guns and 13mm machine guns. Over the course of Yamato's career, as the threat of air attacks grew increasingly more alarming, the number of these guns was boosted significantly, so that by the end of the war she carried no fewer than 150 guns over her original 24. One of the most impressive aspects of Yamato's sheer scale was the inclusion of a vast aircraft hangar enclosed within the stern. 7 float planes, the Mitsubishi F1M2 and the Aichi E13A1, both of which could carry small bomb loads themselves, were housed here, but they would normally be employed for reconnaissance. The hangar was serviced by an enormous crane about 6 tons and 20 meters or 65 feet long, which could pluck the aircraft out of the water after their missions were complete, where a system of rails and bogies would then allow the crew to simply wheel the aircraft back to the protection of the voluminous hangar inside. In fact, there was even ample room for the ship's lifeboats inside the hull as well. Traditionally on other warships, the boats were carried on the boat deck astride the funnel, but this chewed up valuable space that could instead be filled with anti-aircraft guns. Instead, Yamato's designers built 4 huge hangars purely for the array of 14 or so ship's boats, many of them powered with their own engines. The same crane that worked to lower and raise the aircraft could also reach the boats after they were wheeled out of their storage, and by keeping the boats safely tucked away, they were never at risk of being disintegrated by the aft turret's huge blast radius when it fired. So it was that Yamato was completed as a state-of-the-art, terrifying floating platform of destruction specifically designed to engage her enemies with ruthless efficiency. But the huge warship was also home to well over 2,000 men, and Yamato's crew was spoiled. Such a huge hull meant that her men had plenty of space in comparison to other ships of the time. Not only that, but Yamato made use of an air conditioning plant that cooled some of her living quarters and meant crews stationed in the hot Pacific, where temperatures could soar well over 100 degrees Fahrenheit, wouldn't have to suffer inside the oven-like steel hull. Of course, the nerve centre of Yamato was her bridge. In fact, so crucial was the bridge for the operation of the ship that it was encased within an armoured box itself, linked directly to the ship's main citadel deep down inside the hull. Up to 500mm or 19.6 inches of armour protected the senior crew within. And it was here, inside this steel cocoon, that Captain Kosaku Aruga gazed down at his ship's bow as it sped through the waves, and knew well that Yamato, the pride of the Japanese Navy, and arguably the most terrifying battleship ever built, was never going to return home. April 1945 had seen the American invasion of Okinawa, and Yamato, a key military asset, was sent out to interrupt the landings and wreak whatever havoc she could. But Yamato had been built for a different war over a decade earlier. She embodied the spirit of the decisive strike doctrine. She had been built for it, but she never got to engage the enemy battleships she'd been designed to kill. Instead, she'd been thwarted in her attempts to engage the enemy, wounded by submarine strikes, and then kept bundled up in harbours safe from enemy attacks so often that she became known disparagingly by other ships' crews as the Hotel Yamato. Japan had found itself dragged into the kind of long, drawn-out war that planners had always known they couldn't win. Their decisive strike had failed, and the antiquated battleships that Yamato could easily have cut through had been replaced instead by modern, fast American battleships boasting radar-guided gunfire that could give Yamato a run for her money. The battleship duel of the century never materialized. Instead, Yamato was sent on her hopeless mission to become a martyr. Her anti-aircraft armament was boosted, she was joined by 9 other warships, and yet the inevitable still happened. Caught in the open by swarms of American aircraft launched by as many as 15 US carriers, Yamato was hunted down mercilessly from above and struck time after time after time. Engulfed in flames and hit by about 10 torpedoes and more than 15 bombs, Yamato began to list heavily. Her design 20 degrees of stability held up, but she was in danger of exceeding it and rolling over completely. Without any warning passing on to her engineers, her engine rooms were flooded to counter the list, immediately killing the hundreds of men deep down there keeping the ship running. More torpedoes struck her port side, her rudder jammed, and then, limping along, and with her decks a ruined tangle of scorched metal, she began to go. Captain Aruga tied himself to his ship's compass binnacle in the bridge, and he rowed it down into the ocean. Just 2.5 hours after having spotted the first enemy aircraft, Yamato rolled over with a cacophonous roar. And then the unthinkable happened. With hundreds of men streaming down her sides and treading water around the blazing hulk, Yamato's enormous powder magazines erupted. In one of history's largest non-nuclear explosions, Yamato's hull was rent apart by a ball of fury that tore the ship in halves. The monument to engineering had become a pile of scrap metal in seconds. Nearly 3,000 souls aboard Yamato were lost. By shocking comparison, the US had only lost 10 aircraft and a dozen men. Yamato was the pinnacle of a dying breed of warship. But at the time of her design and construction, the world didn't yet know that the battleship had been superseded. Monstrous floating platforms of steel and armour could field all the big guns they wanted, but swarms of tiny aircraft in their hundreds could send them to the bottom with ease. It was a lesson learnt the hard way, time and time again. Repulse, Prince of Wales, Bismarck, Arizona, and then finally Yamato and her sister ship, Musashi. The lesson was so severe that proposed battleship plans for the post-war world were cancelled outright. The last battleship ever built, HMS Vanguard, was in service just 14 years before she was scrapped. Yamato had taken a decade to design and build, but from the moment she first entered the water, she was obsolete. Before the war was over, the Japanese government ordered all of her plans, photos, and information to be destroyed. The first photo of the ship, not taken by US aircraft from above, only surfaced 3 years after the war in 1948. Thankfully today, a few fragmentary records and photographs survive, detailing the ship's construction and her brief career. She was an engineering triumph and an incredible machine of war, but she'd just been designed for the wrong one.